Imagine stepping into a spacecraft and, instead of spending thousands of years traveling to a distant star system, you pass through a tunnel, a wormhole, and arrive instantly. It sounds like science fiction, but wormholes are a real possibility in the equations of physics. Wormholes, also known as Einstein-Rosen bridges, are hypothetical tunnels that connect two different points in space and time. In theory, they could allow for faster-than-light travel, not by breaking the speed of light, but by shortening the distance between two regions of space-time. The concept dates back to 1935, when Albert Einstein and Nathan Rosen first proposed a mathematical bridge between two black holes. This shortcut through space-time came to be known as a wormhole because it resembled a tunnel. A worm might burrow through an apple, taking a shorter path through the core rather than around the surface. So are wormholes real? In theory, yes. Solutions to Einstein's general relativity equations do allow for wormhole geometries. But the big question is whether they can be traversable, meaning safe and stable enough for something or someone to pass through. Unfortunately, ordinary matter can't keep a wormhole open. Gravity would cause it to collapse almost instantly. To hold a wormhole open, you'd need exotic matter, material with negative energy density and negative pressure. This kind of matter violates the known energy conditions in physics and hasn't been observed in the real world. Yet quantum physics hints that exotic matter might exist. In phenomena like the Casimir effect, quantum fluctuations can produce negative energy in tiny regions of space. Could this principle, on a much larger scale, allow a wormhole to remain stable? Some physicists believe it's possible, at least theoretically. Traversable wormholes could connect distant parts of the universe, or even different times. In that case, they wouldn't just be spatial shortcuts, but time machines, allowing one end to lead to the past and the other to the future. This opens up paradoxes and puzzles that challenge our understanding of causality. For example, what happens if you go back in time and prevent your own birth? The infamous grandfather paradox arises. Does the universe forbid such actions, or does it allow multiple timelines to coexist? One proposed solution is the Novikov self-consistency principle, which says events inside a time loop must be consistent, meaning whatever you do in the past was always part of the past. Others suggest the many worlds interpretation, where traveling through time spawns a new parallel universe. Wormholes could also be connections between separate universes in a multiverse. In such a model, a wormhole might link our universe to a completely different one with its own physical laws, dimensions, and histories. If true, wormholes wouldn't just be shortcuts. They'd be all gateways to entirely new realms of existence. But despite the elegance of these theories, we've never observed a wormhole. They remain hypothetical, existing only in mathematics and imagination. That hasn't stopped scientists from exploring the possibilities. Some researchers believe that certain types of black holes, such as rotating or charged black holes, might contain wormhole-like structures at their core. Others have proposed that if tiny wormholes were created in the early universe, they might still exist, scattered across space at microscopic scales. There's also the idea of constructing a wormhole, using advanced technology and exotic matter. Though far beyond our current capabilities, such engineering would require a mastery of quantum gravity, space-time manipulation, and energy sources we don't yet possess. And then there's the question: would traveling through a wormhole be survivable? The tidal forces near the throat of a wormhole could stretch or compress matter to extreme degrees, potentially tearing apart anything that enters. However, if the wormhole is large and stable enough, and if exotic matter properly lines the walls, the trip might be smooth and safe. Wormholes also provide an intriguing tool for exploring the holographic principle. the idea that the universe's information might be stored on a lower dimensional boundary. In recent studies, some physicists have proposed that quantum entanglement and wormholes are connected, that entangled particles may be linked by tiny wormholes, forming a kind of cosmic network. This concept, known as EPR, named after Einstein-Rosen and Einstein-Podolsky-Rosen, entanglement, suggests that space-time itself might emerge from entanglement. In other words, the very fabric of the universe could be stitched together by countless microscopic wormholes. If true, this could revolutionize our understanding of quantum gravity, space-time, and even consciousness. At Infinity Beyond, we don't just chase facts. We explore the boundaries of imagination grounded in science. Wormholes may not be travel routes yet, but they are our portals of thought, pushing us to consider what's possible when we stop thinking in straight lines. In our next episode, we'll dive into one of the most mind-altering possibilities of all, the simulation hypothesis. Are we living in a programmed universe? Subscribe now to Infinity Beyond and let your imagination travel farther than light.